Let us discuss now the introduction to the notion of derivative. Okay, the connection of a derivative with a rate of change. So, remember we discussed in a previous video the tangent line problem, the problem of the tangent line to the graph of a curve. So let's say we want, well, we have a function f of x, and we want the slope of the tangent at any given point. Let's say at the point a f of a, okay? And we discussed geometrically that this should be, yeah, let me create some space here. There you go. So let's say we have something like this. This is our f, okay? And let's use some colors. So this is our point A and the corresponding f of a, and we want the slope of the tangent. Okay, so the tangent is going to be this one here. Okay, this is the tangent at a f of a. Okay, and the way we would find this was using the using second lines, right? So we have different second lines like this, and what we were doing was just bringing these second lines closer and closer, right? Notice what is happening here. These second lines are crossing the function f of x again at the point a plus h. Okay, so what we want is to take h to 0, right? So if you write this down carefully, what is the slope? So the slope is the value of f at a plus h, okay? So it would be this value here, this distance, okay, divided by this distance. But the height is f of a plus h, sorry, not all the way. It goes from the height that we already had, f of a, and then it goes up. So the total gain is f of a plus h minus f of a, and then that gain is over the distance from a to a plus h, and that distance is h. Okay, and then we want to take this h smaller and smaller, so that is a limit process. Okay, so this is the slope. This is the formula for the slope, and this is an exact formula. We will do an example in a moment. But there is another way to write it down, that if you don't want to call the second point a plus h, you can decide to call it, let's say, x. Okay. So then the limit, it would be different, would be a limit. So what is the gain? The total gain would be f of x minus f of a, the height at the end minus the height at the beginning, divided by the total distance, which is x minus a. And then we want x to be closer and closer to a. So the limit as x tends to a. So these are the two possibilities for the slope of the tangent line. Okay. Let's do an example to see how this can actually be useful. So let's say I give you f of x equals x to the power 3, and I want to find the slope of the tangent line at 1, 1. Okay, so first check 1 is in fact in the graph, because when I make x equal 1, x to the power 3 is 1. Okay, that's a quick check. Let's do the two possibilities, the two possible limits. So the limit as, let me first graph it actually, so that we know what we're doing. So we have something like this, right? Let's say this is the point 1, 1. So the tangent is going to be something like this. There we go. Okay, so we want to find that slope. So how do we do? The limit as h tends to 0 of f of a plus h minus f of a divided by 8, correct? First, let's write the formula, then we see what is what. So a, in this case, because we want x equal 1, so a equals 1, and that's it. And f of a turns out to be 1 to the power 3, which is 1. So this is the limit as h tends to 0, okay, of 1 plus h to the power 3 minus 1 divided by 8. And here we are going to need to expand that cube, okay? So this is 1 plus 3h plus 3h squared plus h to the power 3. And then there is the negative 1, don't forget, and then divide by h. There is a cancellation, and then we can simplify 1/8 from the numerator with the denominator. So let's do that. This is then the limit as h tends to 0 of 3 plus 3h plus h squared. And this limit is 3. So the slope of the tangent line at the point 1, 1 is going to be precisely 3. Very difficult to guess if you don't use the limit. Okay, let's do the other definition. The possibility number 2. So in this case, x tends to a, f of x minus f of a divided by x minus a. So in this case, because x is, f of x is x to the power 3, we have x to the power 3 minus 1 to the power 3 divided by x minus 1. Okay, and here we can factor the polynomial, and this is x minus 1 times x squared plus x plus 1 divided by x minus 1. There's a cancellation, and again the limit is 3. Okay, here you see that the two methods are very similar, but they are not exactly the same thing. So we have that leeway to decide which one we want to do. Okay, we need to check both of them to see which one of them looks easier for us. So let me just go over this one last time. So these limits that we have defined, these are called the rate of change, okay? Of f of x at x equal a, okay? And this is basically the definition of derivative. We call this the derivative of f at x equal a, and we denote the derivative. This is a very important notion. We call it f of prime of x, and that is precisely this limit we have just written. Okay, the derivative function is going to be the limit of f of x plus h minus f of x divided by h, or with the other limit when x tends to a. In this case, we will write it f prime of a would be f of x minus f of a divided, that didn't look good, divided by x minus a. Okay, so here the most important thing is that the derivative is the slope of the tangent line. Okay, that's the geometric interpretation, and that is the rate of change of the function.